Hello. Yeah. Good evening, everybody. Yeah, this is my ninth episode, and this is a live streaming. Then I decided let me speak something about automotive technology, uh, something that's very critical, complex, and at the same time the most important part of a vehicle. So that is suspension systems. So today I'm going to talk about what is active suspension and how the active suspensions are configured and how the systems play a crucial role in suspension technology. So as we all know that any vehicle, uh, no matter it's a four wheeler or a bus or a truck or anything which is very cumbersome, so like trailers, especially used for logistics. So these systems uh, are supposed to be carrying very high loadings. There will be a lot of dead loads active. Sometimes there could be live loads also, especially in the state of stator machines used in the concrete industry. So likewise, any kind of loading, uh, there needs to be a proper shock absorbers on the system, the vehicle system, or otherwise there will be a huge impact on the occupant, the passengers or the driver, whoever it might be. So this particular episode, I'm going to give you a small introduction about what are the conventional suspension systems and how did they arrive at an active system. So, which means what are passive systems and what are active systems. So, from passive systems, how the technology has led to the thought about active systems. So all the conventional vehicles, as we know, have got a spring system, a damper system, and usually the spring and the damper combination is usually used for reducing the shocks or the impact loads that comes on the system, on the structure, the automotive structure. So if we try to break down the complete assembly of a car, let us take the case of the car. A car has got a engine system, okay, and then there is a drive shaft. So this engine and drive shaft completely we call it as a powertrain system. Okay, so now from the engine there is a certain work done, and that work done is transmitted to power through the driveline system. So that has got a complete axle systems and your gearbox, etc. Now, apart from these two important systems, we have something called as seating systems. Now, seating systems are the the seats which is kept inside the vehicle, which is firmly arrested or anchored to the chassis. So the complete chassis, as such, when you take, we will find that the chassis has got the seating systems connected firmly, and these seats are different from the usual chairs or the seats that we use in the day-to-day purposes. It's not like that. So there are some additional mechanisms, and these seats are anchored to the chassis, and there are going to be some dampers, and these dampers are springs are usually used for reducing the shock loads or the impact loads that come from the tires. So we have the tires, and these tires are made of neoprene, and every vehicle, okay, is designed for a specific purpose, and all these tires that you find on the vehicle uh, are based on the design, the vehicle dynamic parameters. So there will be the width of the tire, the height of the tire, the radius, all these things matter. And now, whatever undulations or the irregularities or the impact loads that come from the surface, the road surface, is taken by these tires, and the tire will transmit it to the suspension, the above suspension systems, and these suspension systems will in turn transfer it to the chassis and to the seating system. So this is the conventional passive suspension systems. You will have a spring and you will have a damper. So the spring will take care of the stiffness parameter, the dampers will take care of the dampening parameters. So any load when uh, you know uh, when you try to split a load, okay, so that will have a tension factor and a compression factor. So it is like that. And the tension factors or the tension low, forces, strength will be taken care by uh, a certain material, and the compression loads will be taken care by a certain set of materials or systems. So let us say if there is a beam and on the beam there is a load applied, this load is going to get bifurcated into a tension load and a compression load. The compression will act exactly on the fibers which is uh, lying just below the point of application of load, and the tensile loads will act on the region which is totally away from the top fiber. So it will be acting on the bottom fiber. So in between the top fiber and the bottom fiber, we will have a neutral axis, and the neutral axis is the place where the shear force or the bending moment is supposed to be zero. That's the virtual line. Okay, so similarly, whatever load comes on the suspension, okay, will be completely distributed into tension factors and the compression factors. And the stiffness, the tensile part of the load that comes will be taken care by the springs, and the compression factors, whatever comes on the suspension, will be taken care by the uh, dampers. Okay, so this is how all these responses that comes from the surface of the road and in turn transmitted through the tires, and which moves to the suspension, is completely destroyed or disfigured, and then the intensity of the responses are reduced by a certain factor, and then it goes into the seating system. So the occupant will still have or experience the bumps, the vibrations, etc. So what happens is, like, when the vehicle cruises or moves at a very high speed or a velocity, uh, there will be a certain change in the vehicle dynamic parameters. The moment of inertia changes, and as the moment of inertia changes, there will be a lot of forces that will be acting on the vehicle. So, especially during the curves, banking, you'll find that the vehicle is like abruptly there will be a turning, a slip, okay, that experienced by the tires, and accordingly there will be an overturning moment that comes on the vehicle, and then there is a chance for the vehicle to topple or roll and slip out of the track. Okay, so in order to reduce all these, or in order to completely eliminate all kinds of such mm, problems or issues, the car manufacturer uh, came, like combined together. They worked for years together, and then they came out with a process where the vehicle toppling or the roll or the accidents that happens on on bankings or while the maneuvering process, they introduce certain smart systems, okay, which will be able to judge or monitor the undulations of the road surface, the bumps, potholes, etc., at a certain distance. So maybe about 1 kilometer or 1.5 kilometers before itself, and making use of the sensors and GPS systems and all, or using the computer vision systems. uh, the system is able to intelligently detect the nature of surface, the road surface, and accordingly, this will try to create the dampening factors onto the dampers and the stiffness parameters to the springs. Okay, so this will contain a set of combinations. It's not spring or dampers. Instead, you will have systems like actuators. So that is generally hydraulic or pneumatic or electromagnetic, etc. Okay, so making use of these kind of systems, like actuators, sensors, and control systems. Okay, the vehicle dynamics can be adjusted, and there can be a improved ride and comfort. Okay, and the handling process, the vehicle handling process can also be enhanced. So, whatever role is experienced by the vehicle, the stability parameters, and all, like all kinds of uh, systems, I mean, all kinds of issues can be either neutralized or reduced by using these kind of smart material. So, in general, we can say that active suspensions are advanced vehicle suspension systems that use electronically controlled actuators to adjust the suspension in the real time process, offering improved ride comfort and handling. And comparing this to the traditional passive systems, okay, they achieve it through a certain processes. So the actuator elements are either hydraulic, pneumatic, or electromagnetic. Okay, and the set of combinations of actuators, sensors, and controllers, they will be able to read what are all the undulations that comes on the tire, experienced by the tire from the ground surface, and the same amplitudes of forces are reversed. The same amplitude of forces are reversed with the help of the controllers, and that's again induced onto these actuators, okay, with the help of sensors. There will be sensors, all kinds of accelerometers, force sensors, pressure sensors, all kinds of sensors are mounted across the region. So the complete suspension region, the tire related systems, you will have the sensors, and these sensors will take the road data, and these road data are analyzed, and an equivalent and opposite road, the responses are generated onto this unit, the controller unit. And whatever negative or whatever anti forces, you can call it as anti forces, are induced onto these actuators, okay, will be able to completely reduce the impact or the disturbances that generally comes in the case of a passive system. So how the sensors and the control systems are mounted. That's very important. So sensors constantly monitor the vehicle's motion, the road surface, and the driver inputs. This data is fed into a central control unit, and that determines the appropriate force to be applied by the actuators. Okay, so these actuators are ready to take the data from the controller, and the moment it gets the receive the data from the controller, its duty is to create a counter force or counter load onto the system, the actuator system, and based on that, the complete vehicle is going to have the system enabled. That is the active suspension system enabled. So this is what is usually happening in the active safety or the active suspension system. Okay, but in the case of the passive system, okay, we only depend on the spring and the dampers. The spring has got a certain stiffness, the damper has got a certain damping ratio. Okay, and based on the stiffness and the damper parameter, the complete mass of the system changes, and accordingly, see, we generally call it as a steady mass. Okay, we assume that the complete system is a steady mass, and based on that complete steady mass system, okay, the vehicle is adjusted. So earlier, in the case of passive suspension systems, the probability for the vehicle at a very high speed, okay, has got a huge impact. Like there will be a roll, and based on that roll, the vehicle goes out of the road, and then there will be serious accidents, okay, that the vehicle is subjected to. And because of the slip parameters, okay, the road grip and the the tire slip parameters, there is a probability that the vehicle can topple also. So now here, when the active suspension comes into picture, okay, so we'll have to think. I mean, we'll have to try to decide, like, what exactly is the speed or the ratio in which the vehicle is getting cruised. So you would have heard about anti-lock braking system. You would have heard about adaptive cruise control, etc. Now these anti-lock braking systems or adaptive cruise control, okay, they are all again intelligent vehicle systems, intelligent vehicle systems or suspension. It's a part of your suspension system. So the braking happens, and this braking is again decided on certain parameters, the velocity of the vehicle, okay, and the velocity of I mean the complete the velocity of the vehicle, the overall mass of the system, and the complete dynamics, the vehicle dynamics, and it also depends upon the distance between the vehicles. So you are moving in a vehicle at a velocity of, say, let us say 120 kilometers per hour, and there is again a vehicle in the front which is moving at 150 kilometers per hour. So we are trying to overtake that particular vehicle. So when you try to overtake that vehicle, the data are enormous. There should be completely many data which is involved in this particular system. So the data involved are the distance between the vehicle, okay, and